Okay, let us discuss problem number 1.63. So what we have? So problem number 1.62. Before discuss this problem, let us discuss a small theory. So this says, so I have a base and this base is fixed on ground. So this is fixed on ground. Now there are two masses. There is a pulley that is attached here. Are you getting? And through this pulley two masses are attached. Let us say this side I have a mass m1 and this side we have mass m2. So this side mass is m2 and this side mass is m1. Friction coefficient between m1 and the base is, let us say, k1, and friction coefficient between m2 and base is, let us say, k2. The question is, so first part of the question says, what should be the condition so that the system goes in this direction? That is, the system moves along this direction. So first condition, so m1 moves down. So what is the condition required so that m1 moves downward? m1 moves down. What should be the condition, you think? Now you see what will happen once this mass m1 try to goes down. There is a friction force that will act in this direction. That is a m1g. So let us say this angle is given to you, alpha 1 or theta 1. So they say this angle is theta 1 and let us say this angle is theta 2. So you will have friction force will be k1 times m1g cos theta 1 and tension will also act and m1g sin theta will act in this direction. So this m1g sin theta will try to move this downward. This friction force basically try to move up. This tension will also try to move up. Now this block has a tendency to go up. In this case, the friction force in this case it will act downward. And the m2g sin theta will also act downward. So let us say I can separate this as a system and this whole system I can draw something like this. So I can draw this system as like this. Now here I have the pulley. So what we have done is this the curved part. This curved part I have made a simple straight line. So this is mass m1. This is mass m2. Why I am making this? Because now I can neglect the tension. Tension becomes internal force, and that's why I am doing this. Now let us say what the forces on m1 is acting. This force, this side will have m1g sin alpha. So let us say this side will have m1g sin theta 1. On m1 friction force will act in this direction, and this will have a magnitude m1g cos theta 1 and this times k1. Are you getting? So this is k1 m1g cos theta 1. Now if you discuss m2, now this has a tendency to go up. So friction force will act in a downward direction. And m2g cos theta, m2g sin theta will also act in the downward direction. So both forces acting in this direction. So you see m2g sin theta 2 will act in this direction, as well as friction force, that is k2 m2g sin theta 2, that will also act in this direction. Now I want my system should move in this direction. So I want my system should move in this direction. How this is possible? This is possible only if, let us say, acceleration is very little acceleration. Acceleration is 0. This is a just tendency to move in this direction. It's a very small acceleration. So at that time, even this side, this force that is just greater than this side force. So force towards the left side just greater than the force towards the right side. In that case, this system will in this direction. So I can say force towards left side is just greater than force towards right side. In that case, it will have acceleration just equals to 0. Are you getting or not? So system will move in this direction. So let us say force towards left, that is m1g sin theta 1, and any other force towards left, no force. this should be greater than force right. Right are the forces K1 M1 G cos theta 1. This is one force. This is also in the system, plus M2Z sin theta 2 plus K2 M2Z. This should be a cos theta 2 because this is the normal reaction. So this is cos theta 2. Are you getting? So this should be K2 M2Z cos theta 2. So if I take this side, so this becomes M1, this is sin theta 1, M1 sin theta 1 minus M2 sin theta 2, and G everywhere cancels out, so we will have this should be greater than M1 K1 cos theta 1. So K1 M1 cos theta 1 plus K2 M2 cos theta 2 plus K2 M2 cos theta 2. So this is the required condition. So I can write this condition M1 sin theta 1 minus M2 sin theta 2. This should be greater than, so this should be greater than K1 M1 cos theta 1 plus K2 M2 cos theta 2. So this is the required condition you should have if the system moves left direction. Now you can yourself derive what should be the condition so that M1 moves up. This means, so let us say, what should be the condition? You have to derive condition so that M1 should move up. Should move up. So what should be the condition so that M1 should move up? So you have to derive the condition so that now this case M1 should move up. So you think yourself and then we'll discuss the solution. Till those who have not copied can copy. Now let us say if the system moves up, you draw the forces. So this is my system. This is M1, this is M2. Now let us say M1G sin theta will act in the same direction. Only the direction of friction force will change. So this is M1G sin theta 1 in this direction. Here you will have M2Z sin theta 2 that will also act as earlier. Now this block has a tendency to go in this direction. So the friction force, so let us try to see the picture here. If you see, this has a tendency to go up. This means on this block friction force will act in the downward direction. Are you getting? That is the direction of M1G sin theta. So in this case, friction force will also act in this direction. And that is the value will be K1 M1G cos theta 1. Are you getting? Now if you see this block basically has a tendency to go down. So on this block, because I am saying this M1 goes up, so this goes up, so this has a tendency to go down. If this is a tendency to go down, this means friction force will act up. So on this block the friction force will be opposite to M2G sin theta. So in this case friction force will act in this direction. Are you getting? And the value will be K2 times. So let me write here. So the friction force will be K2 times M2Z cos theta 2. So this is the magnitude of friction force. So let us say copy this one and then we'll discuss next. Now system moves this side. So this means I can say force in the right direction should be greater than. So now I can write force in the right direction should be just greater than force in the left direction, because I want my system to move in the rightward direction. So let us say what are the forces that is acting in the right direction. Here you have m2z sine theta 2. So this is the condition in this case. m2z sine theta 2. This is the only force that is acting this side. You're getting this should be greater than other forces. In this direction you have force K2 m2z cos theta 2 plus this force K1 m1g cos theta 1 plus this force m1g sin theta 1. You're getting? Now if I take this side, so this becomes m2 sin, g cancels out, so we will have m2 sin theta 2 minus m1 sin theta 1. This should be greater than K2 m2 cos theta 2, K2 m2 cos theta 2 plus K1 m1 cos theta 1. So this is the required condition you will have in this case. Are you getting or not? Now situation third, this says what should be the condition so that the system remains at rest, that is neither m moves up nor m1 moves down, that is the system remains in rest. This is slightly difficult one. So now what should be the condition so that system, or you can say m1, if m1 is in the rest, m2 will also remain in the rest because they are tied through a string, so m1 is in rest. So what should be the condition so that system is in the rest, that is m1 is in the rest? So this means neither it goes up nor it goes down. So you see we can derive the same thing. So let us say you see the diagram. So this is my system. Now see, this side we have force m1g sin theta 1. This side we have force m2z sin theta 2. Now let us say this does not move. So neither move this side nor move this side. So let us first discuss if this wants to move this side. I does not want the system move this side. This means friction force that is acting in this direction should be greater than this force. So friction force that is acting in this direction, because if this is a tendency to move this side. So if this is a tendency to move this side, friction force on this will act in this direction, and this friction force will act in this direction. So there is a friction force F1, this friction force F2, both will act in this direction. If this is a tendency to go this direction, but I does not want this should move in this direction. This means friction force F1 plus F2 should be greater than, so this friction forces should be greater than, so because this is the friction force that will basically make the system not to move in this direction. This should be greater than m1g sin theta 1 minus, this is the force, this is acting in this direction, so m1g sin theta 1 minus m2g sin theta 2. So this should be the condition so that this system will not move in this direction. So this is a condition so that system will not move in this direction. If the friction force in this direction is just greater than the driving force in this direction, system will not move in this direction. Are you getting or not? And now F1, F2 you know, that is K1 M1G sin theta. So K1 M1G cos theta 1 plus K2 M2Z cos theta 2. This should be greater than M1G sin theta minus M2Z sin theta 2. So this is the condition. Now let us say next, if the system has a tendency to move in this direction, I does not want my system to move in this direction. The forces are m1g sin theta 1, this side will have m2g sin theta 2. Now my system just wants to move in this direction, so on this friction force will act in this direction. On this again friction force will act in this direction. This is F1, this is F2. I does not want my system to move in this direction. So friction force F1 plus F2 should be greater than the forces in this direction, just greater than the forces in this direction. That is m2g sin theta 2 minus m1g sin theta 1. Are you getting or not? So you see what is the condition I am getting. In one case, I am getting F1 plus F2 should be greater than this. In the previous case, you see, I am getting F1 plus F2 should be greater than this. So F1 plus F2 should be greater than this as well as this. Now you see, you basically know the value of F1, F2, so you can write here K1 M1G cos theta 1 plus K2 M2G cos theta 2. This should be greater than M2G sin theta 2 minus M1G sin theta 1. Let us copy this one first. So this is a condition when this system will not move in this direction, and the upper one is the condition when this system will not move in this direction. Now if I combine these two things, I will get system will not move at all. So if F1 plus F2 is greater than this, system will not move in this direction, and F1 plus F2 is greater than this value, so system will not move in this direction. Now basically now we can combine these two inequalities. So let us say this, call this inequality as a first, and this is inequality 2. I want to combine these two inequality. We can always do. So let us try to combine these two inequality. I think you are able to write this one. So the first inequality is F1 plus F2. This is greater than M1 g sin theta 1 minus M2 g sin theta 2. Now the second inequality is F1 plus F2 should be greater than M2g sin theta 2 minus M1g sin theta 1. So if you see these two inequality, basically this has M1g sin theta 1 minus M2. Both have the same term. M1g sin theta 1 is here. This contains also M1g sin theta 1. Now this contains M2g sin theta 2. This also contains M2g sin theta 2. So both have same terms. Only thing is there is a minus. So this term is greater than this, and this term is also greater than this. So this is a negative. So I can say, if this number is, let us say, after calculating this number comes out to be minus 2, so this will come out to be plus 2. So F1 plus F2 is greater than 2, and F1 plus F2 is also greater than minus 2. I can combine these two inequality. I can write F1 plus F2 should be greater than mod of these two. That is enough. If I write mod of M2g sin theta 2 minus M1g sin theta 1, that is the enough. Because if this number is greater than either this as well as this, one is negative, another is positive, So if this is greater than the positive number, let us say this is positive, in that case if this is greater than the positive number, this will always greater than the negative number. So sufficient condition is this should be greater than any of these two that is positive. So let us say take mod. What I am saying this should be f1 plus f2 should be greater than any of these two number that is positive. So positive means I have to take mod, and f1 f2 you know k1 m1 g cos theta 1 plus k2 m2 z cos theta 2. Now this should be greater than mod of either m1 g sin theta 1 you can write, or you can write m2 z sin theta 2 minus m2 z sin theta 2 minus m1 g sin theta 1. So in this case the system will remain in the rest. So neither move left side nor move right side. So this is the condition for system to be rest. So we have derived three conditions. What will happen if system moves up, that is m1 moves up? What happens if the system moves down? In the third situation, what happens that system remains in rest? So using these three conditions how we derived, only thing is that friction force changes. If it moves down, friction force is up. It moves up, friction force is down. If it does not move at all, in that case I have to take both in consideration. What is the tendency, what is the condition for tendency to move left? What is the condition for tendency to move right? I does not want to move left, I does not want to move right. This means friction force should be greater than in both cases. And if I apply this condition, that is the maximum friction is greater than the driving force in the right direction or driving force in the left direction, I will get this desired condition. If I apply these two conditions, I will get this condition. I think all of you are able to understand this one. This is a pretty easy problem, good problem. And we'll discuss the next problem. Let us copy this one fast. I think all of you have copied this one. So let us go for the next problem.